The Brazilian government strictly prohibits any human from stepping foot on the shores of Ilha da Queimada Grande. The island is entirely abandoned, locked down under federal order due to a severe biological threat. Looking out across the water, the sheer isolation of the island becomes apparent. Located 90 miles off the mainland coast, this jagged outcropping of rock is completely cut off from the rest of the world. It is the exclusive home to over 4,000 golden lancehead vipers. They are among the rarest and most lethal reptiles on Earth, dictating the entire ecosystem of this isolated rock. Their venom operates as a highly specialized chemical weapon. Upon contact, the biological compounds immediately begin dissolving internal organs and melting human flesh. For over a century, human absence has left this territory entirely undisturbed. Without any external interference, the island has grown into a sealed, self-sustaining biological fortress where the vipers dictate every rule of survival. To understand the origin of this dense viper population, we have to look back 11,000 years. During the peak of the last ice age, this landform was a continuous strip of coastal hills connected directly to the South American mainland. As global temperatures rose, massive ice sheets melted, sending rapid surges of water into the oceans. This topographic map shows how the surging ocean permanently flooded the low-lying plains. The rising water entirely severed the highest hills from the continent, trapping a small, ordinary population of mainland pit vipers on the newly formed island. As the habitable area steadily shrank, the trapped snakes faced a stark ecological reality. The rising waters ensured that no large ground mammals were left on the forest floor to hunt. Deprived of their traditional prey, the stranded vipers faced immediate starvation. They were locked in an isolated environment that forced them to adapt rapidly or face total extinction. With the ground empty, the snakes had to look upward. The island sits directly beneath a major migratory flight path, bringing thousands of birds into the jungle canopy. But ordinary pit viper venom takes hours to take full effect. A bitten bird could easily fly out over the ocean before the toxins set in, leaving the snake to starve. Surviving this required an extreme biological adjustment. Over thousands of generations, the vipers underwent a hyper-accelerated evolutionary mutation, directly driven by the precise demands of their environment. The chemical makeup of their venom shifted entirely. It evolved to become 5 times more potent than that of their mainland cousins, engineered specifically for immediate impact. The newly developed chemical cocktail works to instantly paralyze the central nervous system of a bird while simultaneously melting its muscular tissues, forcing the prey to drop dead into the branches before it can fly away. The threat of starvation drove a permanent change in their biology. The isolated snakes evolved from desperate survivors into highly efficient, instantaneous predators, calibrated perfectly for their environment. The same rising ocean that trapped the snakes also formed a permanent barrier. It physically prevented any large land predators or competing mammals from ever reaching the shores. Without natural enemies to keep their numbers in check, the golden lanceheads entered a closed-loop ecosystem. They climbed completely unchallenged to the absolute top of the food chain. Supported by a constantly replenishing supply of migratory birds and zero terrestrial threats, their population multiplied rapidly. Current biological surveys estimate an average density of nearly 1 lethal viper for every square meter of the island. This biological dominance covers the entire landmass. The dense jungle, the rocky cliffs, and the shifting forest floor are occupied by thousands of apex predators, existing in unchecked saturation. Yet the very adaptation that makes the island lethal has attracted the attention of modern science. The chemical weapon designed to kill is now analyzed for its potential to save human lives. Because the vipers evolved in strict isolation, their venom is composed of highly complex proteins and specific toxins that exist nowhere else in the natural world. To study these compounds, medical researchers actively risk their own lives, traveling to the island to carefully harvest the precise chemical cocktail directly from the fangs of the golden lanceheads. Initial laboratory syntheses have isolated specific compounds within the slush-melting poison that demonstrate a profound ability to drastically lower high human blood pressure. Further tests show these unique proteins can be structurally modified to prevent blood clots and treat critical forms of heart disease. It presents a stark biological irony. A strictly forbidden environment, governed entirely by death, now harbors isolated molecular compounds that could lead to widespread medical treatments. Snake Island is a clear record of natural selection operating in a closed system. It proves how rapidly biology can rewrite its own rules when separated from the outside world. What began as a standard coastal hill, populated by ordinary snakes, was transformed by rising seas into an incredibly specialized, heavily fortified ecosystem. The island maintains a deep duality. It remains a hostile, inaccessible environment for humans, while simultaneously acting as a locked vault holding potential cures for complex human illnesses. Earth's most dangerous and isolated geographic anomalies often conceal deep scientific value, waiting to be uncovered in the exact places we are forbidden to go.